So in this question, before we can work out the probability that the person picks counters which are different colours, we need to fill in our tree diagram because we have missing probabilities in our tree diagram. So remember that the branches add up to 1, so we can use this to work out what our missing probabilities will be. So we know that the probability of picking a green counter is 7 out of 8. Therefore, if we take 7 out of 8 away from 1, we can work out the probability of picking the blue counter. So that is going to be 1/8. Okay, and if we added them up, we would get 1. So the same thing applies here. So we have 7/8 for picking a green because they've put the counter back, so it's not changing the probability. So again, the probability of picking a blue counter will be 1 minus 7/8, so that'll be 1/8. And the probabilities here stay exactly the same because we've got exactly the same number of counters in the bag as we had to begin with. So the green is 7/8 and the blue is 1/8. Because nothing has changed because the counter has been replaced from being picked the first time, it's been put back into the bag, so we still have 8 counters in the bag. Now we can work out the probability of picking counters that are different colours. And there are 2 ways that counters can be picked of different colours. So we can pick a green counter first and then a blue, or we could pick a blue counter first and then a green. So those are the 2 sort of pathways that we can use to work out our probability. So if we do first of all the probability of picking a green counter and a blue, so a green counter and a blue, then we're moving along the branches, so that will be 7/8. And as we go along the branches, we are multiplying because it's and as well, a green and a blue. So the probability of picking a blue is 1/8. So that becomes 7/8 times 1/8. So you just times the top, so that would be 7, and times the bottom, so that would be 64. So that's one branch, one way. Then the other way we can pick different colours is we could pick the blue first. So if you say the probability of picking a blue and a green, not that it makes any difference the way around it is, but it'd be 1/8. And then we can pick the green counter, so that would be times 7/8. So we're going blue, then green. So 1 times 7 is 7, 8 times 8 is 64. Now because we're going down the leaves, so we're picking the green-blue option and the blue-green option, we now have to add these probabilities together to get the final answer. And that would become 7 add 7 is 14 64ths. Remember, we don't add the bottom because they're the same fractions. And we can simplify that further if we divide the top and the bottom by 2 to 7 over 32. So that would be our answer. So first of all, we need to fill in the missing probabilities, then decide how can we achieve what the questioning is asking us to. So how many different ways can we get counters that are different colours when we pick 2 counters, work out the probability of each root, and then add them together. Now, what would have happened if we'd picked out the first counter and not actually put it back into the bag? So this is when it becomes conditional probability, because what happens about the second counter depends on which counter you picked out first. So when we put the counters back in the bag, we still had 8 counters. But if we're not putting the counter back, we're now only going to have 7 counters in the bag. And we've picked out a green counter and we originally had 7. So now we've only got 6 green counters in our bag. So instead of having 8 counters in the bag, we've now only got 7. And out of those 7, we've only got 6 green counters. And it's the same with the blue. So we now have only 7 counters in the bag because we haven't put one back. And we still have 1 blue counter because we didn't pick out a blue counter to begin with. We picked out a green counter. And the same applies when we do the second tree. So we pick out the first blue counter and we don't put it back. So that will now affect our probability. So now we only have 7 counters in our bag, but we still have 7 green counters because we started with 7 and we picked out a blue one. So all our bag is now full of green counters. And the same with this one. There are 7 counters in the bag. We only had 1 to begin with, that was blue, and we've picked that out of the bag. So we don't have any blue counters left in the bag. So that would be 0. Now, if we wanted to work out our probabilities of picking a counter of different colours, we still move along the branches in exactly the same way and use the multiplication, and we would still add up our probabilities at the end. But you can see how by not replacing the counter in the bag, it has affected our subsequent probabilities. And that is one thing you need to be really aware of when you're working out these probability questions. Has the counter been replaced in the bag, or has it stayed out of the bag and now you have a new number of counters in the bag? That will affect your subsequent probabilities, and that's something you really need to be aware of when you're looking at the question.